guys, welcome to another episode of MrLopezClasses.com. We are going to continue with our course of marine corrosion, and this is the chapter 3. This is the process of oxidation. The phenomenon of corrosion is a process that should be analyzed slow, step by step. For that reason, I start this course, this book, with the basics, with the fundamentals. We start this course with the periodic table, and we study the periodic table, the configuration of the periodic table, why the elements of the periodic table are organized in groups, in orbits, why the metals are located in one side, the metals are located here, and the non-metals over there, and this is the main division in between metals, you remember? In between metals and non-metals, that's the division, metals and non-metals. And we study that the elements in the periodic tables are organized according with the electronegativity, how much energy have the elements, and the elements located in this area are the element with higher electronegativity, and the element located over there, they are the elements with lower electronegativity. And we understand what is the meaning of noble elements, are the elements with more electronegativity, with more energy, and the elements less nobles, the elements with low electronegativity. And we studied that in a reaction in between two different elements, the more noble element attack the less noble element. The less noble element donate electrons, and the more noble attract electrons. And we analyze that the element that donate electrons, the ion of this element will be positive because release one electron and produce a hole. And the element that attract electrons at the end of the day is more negative. The ion of this element in the equation is negative because absorb electrons. And we study that the element that release electrons and release and release and release at the end of the day are eroded, and they are called anodes, sacrificial anodes. And the element that attract elements and absorb electrons more and more at the end of the day are more negative, they are the cathodes. This is a process, this is slow. And we found that the elements located in this area, in this corner, the element with higher electronegativity, normally attack the rest of the elements in the environment. We found that there are 3 elements with high level of energy, and those elements attack the rest of the elements. Basically because they have high level of energy is fluorine with 4.0 millivolts, oxygen with 3.5, chlorine with 3.5, and nitrogen, phosphorus, sulfur, all of those elements are oxidizers. Today we are going to study what is the meaning of that. And the rest of the metals, they are reducers because they prefer in a relation release the electrons, and the oxidizers, they attract electrons. This is the chapter. In this chapter we are going to analyze what is the meaning of oxidation, and what is the meaning of corrosion, and why the elements located in this area of the periodic table with high level of energy, with high electronegativity, they are oxidizers, and why the element located in the left bottom side of the periodic table in this point, they are called reducers, because they release electrons when they are combined with other elements. This is the process of oxidation, and we are going to analyze what happens when the elements with high energy attack the elements with low energy. The oxides are produced, and what happens when the oxides are mixed with water? What happens? Produce acids, produce salts. Exactly. This is a wonderful chapter. And this is important in the process of the study of the phenomenon of corrosion. And some of my students say, Mr. Lopez, this is too complicated. I want to know what is the sacrificial anode recommended for my boat, and that's it. Alright, but this is a course of engineer. And if you want to be a successful engineer, you need to know what happened. Because let me explain something. Only replace the sinks is not the solution. Because yes, the sinks, the sacrificial anodes, are the protectors of your boat. But the zinc, the magnesium, the aluminum, the sacrificial anode should be properly selected. Depend of what? Depend of the type of water. No, it's salt water. But excuse me, where is located the boat? In the Caribbean? At north? At south? In the Pacific? It's different. Depend of the salinity of the seawater. Depend of the temperature of the seawater. This is one factor. Other factor is what is the material of your of the hull in your boat? My boat is aluminum. Okay, that's different. My boat is fiberglass. No, my boat is carbon fiber. No, the boat is ferro cement or is iron. There are a lot of materials. Is wood. It's different. Other question. Your boat is a DC boat or AC and DC? No, in my boat I have AC and DC. That's different. Yeah, depend of a lot of factors. A lot of factors. The corrosion is accelerated, or the corrosion is neutralized if you select appropriate materials, if you select appropriate sacrificial anodes. It's not easy. If you are an inspector, if you are a surveyor, if you are the engineer, the manager of a marina, you need to be clear with the concepts related with the corrosion, because each boat is different. Each boat, the configuration of each boat is completely different. There are boats with only DC power. There are boats with AC power. How is the ground of my boat? How is the bonding of my boat? Is properly connected? Is properly wired? My AC panel and my DC panels are properly wired? The metallic elements inside of the boat are properly connected with the bonding? The cable of the bonding, the terminals are properly crimped and protected? There are millions of factors. How is the connection in between those two hulls, for example? It's in series, one cable passed for the other. But excuse me, it's broken in that point. Right now the series is disconnected. For that reason, the rest of those fittings, those two hulls, are completely corroded. There are a lot of factors. This class is the end of the program. For that reason, I locate in my program, in my curriculum, the curriculum that I organize, this class at the end. Because you need to know about electricity a lot. And we are going to talk later in the next coming chapters about the configuration of the AC and DC panel, the wiring, the bonding, in order to identify where is the leak of current. Because I have corrosion in my boat. The sinks are, the anodes, the magnesium or aluminum sacrificial anodes are perfect, properly installed. But my boat is corroded. You have a leak of current. Where is the leak of current? Is in the DC side? Is in the AC side? Where is located the leak? Which is the device that is producing that leak of current? Is an engine? Is a generator? Is a water maker? Yeah, is an appliance? Where is the leak? And how I know if this is the leak? How can I identify the leak? How can I measure the leak? In volts? In amps? In ohms? What tool can I use to check the leak? All of those are questions. If you are a good manager, a good surveyor, a good inspector, you need to be clear with those concepts. And for that reason, we start with the basic, with the fundamentals, with the atom. After that, we divided the periodic table in metals and non-metals. And after that, we understand that the elements are located according with the level of energy. And after that, we study that when the elements are close one with the other one, the element with more energy try to attack the element with less energy, and a small arc of electricity is produced in between both of them. That arc eroded the less noble element. And we found that in the environment, we have one element with high level of energy, practically the maximum. And that element oxidized, that element corrode everything, is oxygen. Yes, this is oxidation. It's the phenomenon of oxygen attacking the rest of the elements. That's it. This is oxidation. Right now we are going to study with more precision what is the meaning of that. For that reason, we need to go step by step. If you want to be a successful engineer or inspector or manager, you need to understand what happened. Because each boat, each situation is completely different. Once again, the solution is not only install the sacrificial anodes and that's it. Bye-bye. Replace the anodes and bye-bye. Hey, Mr. Customer, your boat is ready. I replace the anodes. 2 weeks later, I don't know what happened. The anodes loose like new one, and my boat internally is fully corroded. The problem is not on the sacrificial anodes. You have an internal problem. This is the situation that we are going to study. This is the situation that we are going to analyze. You need to understand the fundamentals. If not, after that, it's not possible. You have a lot of holes. Alright, for that reason, we are going to continue. And now, in this chapter, we are going to try to understand what is the meaning of oxidation. Yes, we are going to check how the oxygen attacks the rest of the element. Oh, the oxygen only attacks the iron and that's it. No. The oxygen attacks everything. Yes, you have oxidation on the fiberglass. Yes. For that reason, you need to select the appropriate hardware. When you fix it, brackets on the fiberglass, you need to use appropriate marine grade stainless steels. You remember in the previous episode, Series 300. You need to select appropriate non-ferrous alloys, like a nibral, like a monel, because there are ferrous alloys not good for this environment, for the marine environment. There are non-ferrous alloys not good for the marine environment. No, it's non-ferrous. Brass is not good, because brass have a lot of zinc, and the oxygen, love it, the zinc, and attack those fittings. Okay? Yes, the periodic table, if you remember, we are going to refresh quickly. The elements located here in this area, they are metals. They are metals. And the elements here, non-metals. And the metals, they are divided in alkali metals, alkali earths, transition metals located here, transition metals. Those are semi-metals, but all of them are metals. Okay, those elements located here in the bottom, they are the series of lantaniums and the series of actiniums. Those are elements, rare elements, because those elements are coming from the laboratory, synthetic. The rest of the elements here on top, they are natural elements. The bottom one, they are synthetic elements. For that reason, they have the majority of them, the last name of the inventor, the last name of the scientific, the engineer that discovered that element. Okay, but for our study, we are going to be concentrated in the natural elements that are corroded every day because of the environment produce corrosion. And now we are going to start with an special analysis. We are going to try to understand what is the meaning of alkalinity and salinity because this is other factor that affect the process of corrosion. The majority of the people say, oh, I prefer alkali solutions. I am going to eat alkali food, no more acidic. No, you need the balance. You need acid, yes, you need acid. You need some level of acidity in your body. You need some level of alkalinity in your body. We are going to study later in the next coming chapters about the pH and why is important that your body be in the middle at levels 7, around 7, because it's neutral. You need some amount of acidity, some amount of alkalinity. If your body is stable in the middle, your body is clean. This is important, this is critical. For that reason, not only alkali solutions are good, not only acidic solutions are, you need a balance. Exactly the same with your boat. You need a balance in between the electrolyte, is the water, and the boat, the materials of the boat. You need to keep the balance in acidity, in alkalinity. Both extremes, too much acidity, too much alkalinity, produce corrosion. Both extremes, high acidity, acids, or too much alkali, both of them attack. For that reason, you need be in the middle. You need be stable. Exactly the same like your body. With your boat, we have the same situation. And yes, we are going to try to understand what is the meaning of alkali materials, alkali elements, alkali solutions, and acidic solution, acidic elements. We need both of them in order to neutralize the equation. Alright. It's clear, the periodic table, and now we are going to start with the process of oxidation. Yes, because the oxygen have more energy, the oxygen attack everything. The oxidation state of an element is related with the number of electrons that the atom lose or gain when it's combined with other elements. This is the first approximation to oxidation. It's also determine the ability of an atom to oxidize, gain electrons, and reduce, release electrons. Yeah, this is the first definition, the first term that we are going to introduce in our nomenclature for this class. Is oxidation and reduction. Right now we are going to explain what is the meaning of that. Oxidation is the interaction of oxygen molecules with other metals with less electronegativity. Yeah, it's the interaction of oxygen with other metals. That's it. Oxidation is the process of either stealing or donating electrons. When the electrons are stolen or donated, the metal will be solved in water. Now we are going to check what is the meaning of that. There are a lot of examples. The oxide of the metals are good example. This is the oxide of aluminum. This is oxide of aluminum, and this is oxide of iron. I explained in previous episode how is the configuration of those molecules, of those compounds. The majority of pure metals, I explained in previous episodes, they are coming from oxides. The majority of the pure metal that you have in the environment, except three, you remember? Okay, except gold, copper, and platinum. Those are natural elements. You found those elements in natural state. The rest of the elements are mixed with other elements, with carbon, with hydrogen, with oxygen, with sulfur, with phosphorus, and you need a special process to separate those impurities and get the pure metal. No? The majority of those metals, they try to return to the original form. The original form of the majority of them is oxides. For that reason, if you let a piece of metal in the environment for 2 or 3 days, and you check in 3 days, you found a lot of powder over the metal. This is oxide of that metal, because the metal tried to return to the original state. The original state in the majority of them is oxides. Okay, for that reason, they just need some atoms of hydrogen and oxygen to return to the original position. Yes, and they founded those atoms of hydrogen and oxygen in the environment. It's simple. The hydrogen in the humidity of the environment, and the oxygen in the air. Remember that the air, the composition of the air, the majority is nitrogen, but the oxygen is that small section. Yeah, not all the air is oxygen. The majority of the air is nitrogen. Okay, my friends, oxidants and reducers. For example, oxygen, fluorine, chlorine, they are very strong oxidants because they are in the corner that I explained before. On the other hand, metals like lithium, sodium, they are perfect reducers. Yeah? Those elements at the end will be oxidized because they are reducers. They release electrons. And the oxidants attract electrons. Yeah, this is the typical process. Reduction and oxidation. The donor is called the reducer. That's it. That's the donor. And we are going to check examples. For example, you remember the salt that you use to prepare food? What is the formula for salt? Is sodium and chlorine. Chlorine with 7 electrons in the last orbit only need one more additional electron to be stable. And this element, sodium with 1, release the electron. What is this? This is the reducer. And what about chlorine? Is the oxidant. Oh, perfect. This is a great example. One is the oxidant attract, and the reducer release electron. Finito. Bingo. That's it. This is the explanation about that. And at the end, for example, the chlorine attack, in this example, the chlorine attack the sodium and is produced salt. What is the name of the salt? Is the product or reactant. Is the final product. In our particular example, if we have a sodium and chlorine, we have the final product is salt. The final product is salt. Finito. Okay, it's clear. Biodiesel. Biodiesel is another great example. Biodiesel, we have vegetable oil. You remember in our class of diesel, the procedure to produce biodiesel. You remember that formula that I put on the board? Is vegetable oil. You preheat the vegetable oil, and in a separate container you prepare methanol mixed with hydroxide of sodium or hydroxide of potassium. This is an alkali solution, and you mix the vegetable oil with the other elements, and you have a biodiesel and glycerin. That's it. This is a wonderful wonderful episode, how to prepare biodiesel, that episode. Alright, my friends. Yes, you have the vegetable oil, and this one, what is this? This is the hydroxide of sodium, or the hydroxide of sodium. And the methanol. And finally, you have a glycerin and biodiesel. And at the end, you have the biodiesel on top and the glycerin in the bottom. Okay, those are the products. And those are the reactants. You like it? This is another great example. Okay, right now we are ready to check the definition of oxidation and corrosion. I checked in different books of engineer, different writers, different scientifics, and there are a lot of definitions about oxygen and corrosion. But in general, a good definition for oxidation is the process where the electrons are drawn away by free oxygen molecules. It's a good approximation. And they say that the corrosion is the chemical or electromechanical reaction that produce that the material be disintegrated with the environment. Okay, but I have another Lopez definition. Oxidation is the combination of oxygen with different materials. That's it. It's the reaction in between oxygen and different materials. This is oxidation. And corrosion is the accumulation of oxidation. Is when you have progressive oxidation day per day. At the end of the month, at the end of the year, you have corrosion. Simple. Oxidation is the interaction in between oxygen and any metal or material. And corrosion is the accumulation of oxidation. Finito. Simple. Okay? Alright, we are going to try to keep that concept clear, because in the future we are going to use oxidation or corrosion. Yeah, when you found it, a piece of metal like this is corroded. It's fully corroded. But if you found that other piece of metal like this is oxidation. Yeah, simple. Corrosion is the accumulation of oxidation. Finito. And you can collect that excessive amount of oxide of that metal. You need clean. But if you check the original metal, it's less, because was completely eroded because the corrosion. Okay, this is a good definition of corrosion. Okay, and now we are going to start with the definition of oxides, and we are going to divide the oxides in two main groups: when the oxygen attack metals and when the oxygen attack non-metals. Okay. When the oxygen attack non-metals, produce acidic oxides. And when the oxygen attack metals, produce basic oxides. And after that, we are going to check what happened when those oxides, acidic oxides and basic oxides, are combined with water. What happened? What is the result? Alright? We are going to start right now. An oxide is a chemical compound of oxygen with other chemical element. That's clear. The oxide with only one oxygen are monoxides, like a carbon monoxide, because it's with only one oxide, with one atom of oxide. And the carbon and the carbon dioxide is with two atoms of oxygen. Okay, now we are going to check the definition clear about oxide. There are two types of oxides, basic oxides and acidic oxides. I explained before. Acidic oxide is the combination of oxygen plus non-metal. Simple. For example, oxygen and sulfur. Sulfur oxide or sulfuric oxide. Depending how many electrons in the last orbit release the sulfur. For example, sulfur is located in the periodic table in the group number 6. Sulfur produces 3 different types of oxides, because sulfur with the 6 electron in the last orbit can release 2 or 4 or 6 electrons and produce 3 different oxides, right? Nitrogen is located in the group number 5 with 5 electrons in the last orbit. When the nitrogen is combined with oxygen, the nitrogen can work with a 1 electron, release only 1 electron of the last orbit, or 3 or 5, and produce 3 different oxides of nitrogen. Yeah? For that reason, we have a sulfurous acid, sulfuric acid, sulfurous oxide, sulfuric oxide. It's depending how many electrons release the atom when the atom is combined with the oxygen. Yeah? Alright? Though acidic oxides is basically the combination of oxygen and non-metal. For example, oxygen plus sulfur, oxygen plus phosphorus, oxygen plus nitrogen. Those are acidic oxides. And basic oxide is the combination of oxygen and metals. For example, the combination of oxygen with calcium, the oxygen with sodium. Remember, the group number 1 are alkali metals, the group number 2 are alkali earths, 1 and 2 are alkalis. The middle ones are transition metals. Oxygen can be combined with iron, ferrous oxide or ferric oxide, and the oxygen can be combined with aluminum oxide, or the oxygen can be combined with zinc, oxide of zinc. Yeah, those are basic oxides. Simple. Advantage, for example, the acidic oxides, they don't react with acids, but when they are mixed with water, they produce acids. And the basic oxides, produce hydroxides, I'm going to explain right now, and salt. This is the next part of this explanation. It's clear, my friend? This is the combination of oxygen with different elements, with metals or non-metals. The oxygen with metals produce basic oxides. The oxygen with non-metals, acidic oxides. There are a lot of examples of acidic oxides. An oxide, if I have an acidic oxide and this oxide is combined with water, produce an acid. Exactly. An oxide that is combined with water produce an acid. All the acidic oxides combined with water produce acids. And I have a lot of examples. For example, this molecule, oxide of sulfur plus water, produce sulfurous acid. Carbonic acid is CO2 plus water is carbonic acid. Sulfuric acid is SO3 plus water is sulfuric acid. Yeah, it's the combination of the oxide, the acidic oxide with water, produce acids. Simple. Yeah, this is the example. Yeah, it's the water plus the acidic oxide, and the product is acid. Is the acid. And basic oxides, there are a lot of examples of basic oxides. Is oxide of metals, for example, oxide of calcium plus water produce hydroxide of calcium, hydroxide of magnesium, hydroxide of sodium. All of those compounds are alkali compounds because it's the combination of oxide of metal. In this particular case is oxide with alkali metals, and now plus water produce alkalis. Keep in mind that name, alkali, because later we are going to use those products, the alkali products. There are a lot of examples. A basic oxide is an oxide that shows basic properties in opposition with the acidic oxide. The basic oxide react with water to produce base. The basic oxides react with acid to produce salt. Example, for example, oxide of sodium. Oxide of sodium is react with water to produce sodium hydroxide. Magnesium oxide react with a hydrochloric acid to produce magnesium chloride. This is salt. This is a salt. Copper oxide, when the copper is working with 3 electrons in the last orbit, react with nitric acid to produce nitrate of copper. This is another salt. Those are basic oxides and acidic oxides. Basic oxides and acidic oxides. Basic oxide. The general property of a metal oxide is that they tend to react with water to form basic solutions of metal hydroxide. There are a lot of examples. Hydroxide of magnesium. Is basically the combination of magnesium with oxide of magnesium with water and produce hydroxide of magnesium. Hydroxide of magnesium. Remember that when you have a compound, when you have a molecule, the element that donate become at the end of the day positive, and the element that attract become negative. Those are the ions. For example, in the previous formula, we have the magnesium. The magnesium release electron and become positive. This is the positive ion, and the hydroxide absorb electrons and become negative. At the end of the day, the molecule is stable and is zero. The charge of the molecule is zero. Okay, my friends, and the acids. There are a lot of examples, but we are going to talk later about that. In general, the people say acid if the formula have hydrogen is an acid. In general, yes. If you have acids are compounds that contain hydrogen. For example, hydrochloric acid, sulfuric acid, nitric acid, because contain hydrogen. But be careful, because there are compounds, there are formulas with hydrogen and it's not an acid. For example, water have hydrogen and is not an acid. Methane, cetane, they have hydrogen and they are not acid. Not all the formulas, not all the compounds, not all the molecules with hydrogens are acids. Be careful with that. Okay, but in general, yes. Hydrochloric acid, sulfuric acid, phosphoric acid, carbonic acid. There are a lot of examples of acids. In general, is because they contain hydrogen. Now we are going to continue with the analysis of organic and inorganic acids. The difference is exactly the same like the difference in between organic and inorganic chemistry. Organic chemistry is the chemistry based on carbon. Carbon and the relation with the carbon with the hydrogen, carbon with the oxygen, is the study of carbon is organic chemistry. Inorganic chemistry is the study of the rest of the elements, included carbon. Exactly the same with the acids. Organic acids are acids based on carbon. Carbonic acid, carbonous acid, those are organic acids. And inorganic acids are The rest of the acids with no carbon. Simple. This is the main difference between organic and inorganic. Don't forget, the key word is carbon. And this is the main difference. Yeah, carbon and non-carbon. Organic acids occur or can be produced from animal and vegetable matter. In addition, with the hydrogen and oxygen and other elements. Those are organic acids. Inorganic acids contain no carbon, are called mineral acids. And the most common are sulfuric acid, phosphoric acid, nitric acid. Those are inorganic